Okay, so in this video we're going to talk about how do you find the electric field around a uniformly charged object at a point around the object. So we're going to put some steps onto this, and we're going to use a simple example of a one-dimensional object as we go along. So let's consider our first step. Our first step is as follows. You want to consider only a small part of your uniformly charged object. So imagine you have this one-dimensional wire and its net charge is positive. So you can easily describe this as a set of positive charges, all next to each other along one axis or dimension. And then, for argument's sake, let's say we want to know the electric field at this arbitrary point over here in green. And this is located at a distance A, vertically away from the wire, and on an axis along the wire of length L. Let us say it is at a point midway along that axis, L over 2. Okay, so here's where we start doing the first step. Let us say that this is just one of the many charges that comprises the wire, and we will call this a small amount of charge. Let's call this dq. I could have just as well called this delta q, but you'll see the motivation for why we want to do this as a differential instead of a finite quantity. So remember, this is a differential amount of charge. And we will see that the electric field due to this will be dE. Now, that's pretty much it. That was our first step. So, in the next video, we're going to consider what the second step is.